morning, students. Hope all are follow my previous videos. I am expecting everyone follow my previous videos. So last class we discussed this topic, that is idea of efficiency of algorithms with examples in live class. How to calculate complexity of algorithms by using examples. We are discussing previous class, loop statements, nested loop statements, consecutive statements, and mixing all these statements, if then else statements, sequence statements. All these statements we consider with examples in previous class. Today we discuss about the concept of see this best case, average case, average, and worst case complexity of algorithms. Complexity of algorithms. So in this we consider through examples which is the best one, which is the average, and which is the worst case when we calculate complexity of the algorithms. Take one example here. See, I am taking a list of elements. So 52, 31, 35, 23, 17, after that 5. So I am taking here 3 plus 3, 6 elements. So our input size is equal to 6 numbers, that is 6, that is n. Here size of the input n is equal to 6. So I am taking 6 elements here. I search my search key element, search key element is equal to, for example, 52. My search key element is 52. So in this problem I am searching 52 element, where it is placed in this list of elements. When I am searching all these elements, first I am searching for starting from 52. My key element is compared with this one. Here in the first case when I am comparing with the this element with this element, both two are matched. So this is the best case. So in this case I am not considering the remaining comparisons. Why? Because my key search element is placed in first position, and then I display the position of this key search element is 1. First place it is displayed. That's why here this is the best case. Here only I am doing only one comparison here. I am not doing all the comparisons. Why? Because we are not comparing remaining elements with this key element. Here my search key element find out in first position. That's why you are not providing any comparisons with remaining elements. That's why this type of searching, so this type of problem solving is called as consider best case complexity. So best case complexity means minimum number of, when you are taking input size n to solve a particular problem, the input size is n. So the time taken, how many steps we are taking here? I am taking minimum steps to solve this problem. So when we compare input size n and I am solving this problem with lesser amount of steps, that is time taken to solve this problem is very less. That's why minimum time I am taking here. That minimum time to solve that problem, when the input size is n, the time taken is minimum, that is calling it as best case. So here minimum time or size we are consider here. Time taken here, minimum size. For example, okay, I am searching for my searched key element is not a 52. Okay, in this case, I am searching for okay. See, I am searching for 23. My searched key element is 23. First I compare here key element, our input size is 6 numbers. N is equal to 6. So first I search with first number 23 to 52. So key search not found here. Then again I am searching with second number 23 to 31. Here also search key search not found here. Then again I am compare with 23 with 35. Here also failed. So again I am compare with this number with next number by using the for loop here. By using the for loop here, total how many steps are there here? I am considering input size n, and I am taken 1, 2, 3, fourth step. Okay, my key search element found in the for loop. Okay, so here total number of elements is 6. So all the 6 elements we search, minimum we require 5 to 6 steps to continue the search, but we are taking in we conclude our search element find out in fourth step. That's why it is considered as average time taken to solve this problem. So here for doing this task searching element, okay, I am taking 4 steps. 3 comparisons failed, but fourth time it successfully returns. Okay, the key search element is found. So this is the case when we consider average case. So average case means the time taken to solve that problem, the average number of steps we require here, that can be considered as average case complexity. So minimum number of time taken to compute that to solve the problem is calling it as steps. That is calling it as best case. This one is average case. And the worst case is suppose, okay, I am searching here, my search element is 5. In this third example, I am taking my search key element is 5. First I compare my search key element with 52, but here comparison failed. Then I compare 5 with 31, here also failed. Then I compare with 35, failed. Compare with 33, failed. Compare with 17, failed. So I complete all the 5 steps, and last step 5 compare with 5. Here no elements are there. This is the last element searched in my list. So here in this case both numbers are same. So the searching is successful, and the position of the searched element, that is in our list, is 6th search successfully executed, and it found the position in 6th position. So in the last case the searching element is found in the list. So that's why it is calling it as worst case. Here we compare all the 6 elements with the searched key element. In the first case we consider only 1 step. In the average case we consider 4 steps. In the worst case we consider all the steps to compare with the key element. So that's why the time taken to solve this problem, we consider maximum number of steps to consider for doing this task. That's why it is calling it as worst case complexity. In this way we consider, or we count, or we compute complexity of algorithms: best case, average case, and worst case. When all these we consider, then we prepare a chart or graph best case, average case, worst case, probability or computation complexity. Okay, the worst case and the average case are taken so much of time. For worst case it takes so much of time, maximum time it takes. Okay, this is the complexity, actual complexity. Why? Because when we solve a problem, we consider maximum number of time taken to solve that problem, always consider. Okay, so in some cases we consider minimum cases, average cases, but every time we consider when we calculate any particular algorithm, so complexity, we consider worst case scenario or case. So we draw, okay, the best case and worst case and average case complexity of algorithms according to your textbook. Here, okay, we draw this algorithm. Here input side, this one is input size, that is n. So we are taking n inputs. So our input size is n, time taken, this one is x-axis. X-axis is considered as input size. So how much of input we are taken to solve this problem? So here time taken, y-axis is time taken, that is steps required. Steps required to solve the problem. Okay, see here, this one is time taken, number of steps required. Number of steps required to solve that problem. When we consider here this graph, so this one is worst case complexity of curve. This one is average case. This one is best case. Always when we consider best case, average case, worst case complexity of algorithms, always best case is requires minimum number of, see this one is always in this manner. So the time taken, when our input size increase, the time taken also minimum size it requires. But the worst case, when our input size increase, the worst case complexity is increased. The best case or average case, always the time taken is average. Number of times or steps we require. So in this way, we calculate best case, average case and worst case complexity of algorithms. In the previous class, we discussed when we explain the concept of if then else, okay, statements, we consider worst case complexity. Why? Because if the condition true means it is best case. Suppose, okay, the condition false means we first execute if the condition is, checks whether the condition is true or false. Computation is required. After that, we go for else part. Then we execute, evaluate else part, all the statements. That's why we consider any construct with the number of worst case complexity we are considering. Okay, that is when we are dealing with the time complexity, we consider most cases worst case complexity. Next, coming to, we take another example here by doing this. So best case, best possible, best case, average case, next worst case. So best case means minimum steps. Average case means average steps. Here maximum number of steps consider. Maximum steps we consider here. So best case means minimum steps we require. Average case means average number of steps we require. Worst case means maximum number of steps we consider to solve a particular input size. All these cases our input size is n. When we are taking input size n, we calculate it is a function of n. So minimum steps, average steps and maximum steps to compute the complexity of best, average and worst case complexities. So consider an example. So how to calculate time complexity of a program. See, I am taking one program here. Okay, see here I am writing one program here. So example 7.1, determine the complexity of a program that checks okay, if a number is prime or not. If a number is prime or not. So how to solve this problem? So determine the complexity of a program that checks if a number is prime or not. This can be solved in two ways. So this problem can be solved in two ways. Today we discuss only one way. Next class, in my next video, I explain the second alternative way how to calculate this checks if a number is prime or not. So two ways to calculate this problem, and in two ways we calculate the time complexity, and we decide after that which one is the best one when we consider this problem according to time complexity. So this problem I explain. So first we check, we consider this one is n is equal to int input of enter a number. So first we enter a number. Next we check prime flag. Initially prime flag is 0. Initially prime flag is equal to set to 0. Next we consider for loop for I in range of 2, n. Okay, if here the logic is n percentage I is equal to 0. Okay, so this consists of prime flag. Okay, prime flag is equal to 1, break statement here. Next, if prime flag is true, print n is a prime number. Here we print a prime number. Okay, next, yes, if the prime flag is false, okay, print n is not a prime number. N is not a prime number. See, when we consider this example to calculate whether the given number is prime or not, first we enter a number here. So here n I am entering. Suppose how to calculate this logic? First we enter a number. Okay, suppose I am entering number 5. So 5 is initially prime flag set to 0. Suppose. So after calculating final the prime flag, you check whether it is equal to 0 or whether it is equal to 1. Initially we set to 0. So for I in range 2, n. Why? Because here we consider that number 5 can be divided with, so always every number divides with 1 and divides with 1, then we get the result, the 0, that is not quotient, that is remainder is always 0. That's why we will not divide with 1. That's why we not taken here 1. So we divide this number with starting from 2 to n. So 2 to n means we start with 2, we consider up to n minus 1. Up to n minus 1. Why? Because every number divides with that number always returns remainder 0. That's why we consider start with the range of 2 to n means n minus 1 here. Then we consider we divide this remainder. We divide the I with that number. Okay, n with divide with I, it returns whether it is returns means remainder is check whether the remainder is 0 or not. If the remainder is 0, prime flag set to 1. So already prime flag set to 0. Then if it is returns 0, then we set prime flag is equal to 1. After that break. So each and every time we calculate. Okay, 2, 3. Suppose I am taking n is equal to 5 here. Okay, so I am dividing the 5 with 2. Okay, it remainder is not equal to 0. That's why here prime flag. Okay, initially 0. Okay, so when we divide with 5 with c, I is equal to here 2. Okay, so 5 divides 2 with remainder is not equal to 0 here. That's why prime flag is not set to 1. Okay, then if prime flag not set to 1, then again we divide with I is equal to 3. Okay, then this time also it is not divided with 5. Okay, not 3. Okay, then we consider 4. Then we consider, so 5 divided by 4 is not equal to 0. So remainder, we consider here remainder. So when we consider 2, 3, 4. So we not consider 5. Why? Because every number divides with that itself. Always its remainder is 0. It returns remainder 0. That's why we not consider here 5 by 5. Not consider here. And we not consider 5 by 1. So in this case, we calculate not 5 by 1 and not 5 by 5. These two always returns remainder 0. Then we calculate out of all these remaining numbers, we check okay whether the remainder is equal to 0 or not. In this case, so if the more means here every number, okay, every number, okay, having 2 factors, we calculate here factors, 2 factors, every number having at least 2 factors except 1. Okay, so if more than 2 factors having, that means that number is calling it as a prime number, otherwise it is not a prime number. So if 5 having only 2 factors, that's why it is calling it as a prime number. So finally we print the message 5 is a prime number. So if prime flag, so in this case always prime flag set to 0. So that's why prime flag not set to 1 in any time. That's why if prime flag is not set to 0, so n is a prime number. So it is set to 0, that's why it is true. Always prime flag is equal to 0 in this when we consider n is equal to 5. That's why here 5 is a prime number. It is not a composite number, not a prime number. So 5 is a prime number. Why? Because 5 having only 2 factors. We not consider 1 and 5. Remaining numbers 2 to 5 minus 1, that is 4. We compare here with 2, with 3, with 4. Not with 1, not with 5. So that's why in this way we calculate here how to Okay, in this logic, we calculate whether the given number 5 is having only 2 factors or more than 2 factors. If the given number having only 2 factors means flag returns 0. Here in this case, flag anyway flag not changed to 1. That's why it is a 5 is a, finally we print 5 is a prime number. Suppose I am taking 6. In place of n is equal to 5, we replace n with 6. Here it displays 6 is not a prime number. Why? Because here when we divide with 6 with 2, it returns remainder 0. That's why flag changed to 1. Whenever flag changed from 0 to 1 means it has more than 2 factors. When a number having more than 2 factor means it is not a prime number. It is a composite number. By using this logic, we calculate here whether the given number, okay, is prime or not. So then we calculate here the time complexity for all these statements here. See, here when we consider each and every step, okay, here this one is one statement. Here this one is one statement. We are taking input value. That's why the constant is C0. For example, in this case C0. Next, this one is one statement. That's why constant taking it as C1. Okay, so C1, C0 plus C1. This one is for loop. This one is for loop. Okay, this for loop executes nearly, not, okay, relatively, absolutely or nearly n times executes. Okay, n times executes. That's why for loop completes n rotations nearly. So here this one is if statement. So this if statement having some condition. To evaluate this condition, so constant time we assume here C0, C1, C2. Okay, this one is constant time to execute, for example C3. So the time taken to execute prime flag is equal to 1 and break statement is C3. Okay, we consider this one as C3, this one as C2, this one as nearly n times. So the total for loop to complete this n into C2 plus C3. N into C2 plus C3. Next we consider here one condition. Okay, this one is one statement. So this one is C4, this one is C5, this one is C6. Okay, so how to calculate this total time complexity is here. Okay, so for first two statements, time complexity is the total time complexity for two statements is C0 plus C1. Okay, first two statements n and prime flag is equal to set to 0. These two are consecutive statements, continuous statements C0 plus C1. Then when we consider this for loop, the time taken is here n times it is repeated yearly, and this one is C2 plus C3 plus C4. C2 plus C3 plus C4. That's why C2 plus C3 plus C4 into n times. So here n times for loop repeated, and the body of the loop for loop consists of if statement condition for C2 and C3 prime flag set to 1 and break statement can be considered as C3. So we consider here only C2 plus C3 into n. C2 plus break statement and prime flag set to 1 is considered as constant C3. So C2 plus C3 into n. Then again plus if part C4 plus C5. So we consider C4 plus C5 plus C6. Last else part consists of the statement C6. In this way, the total time complexity we calculate here. This one is constant time, this one is also constant time. Constant into n value plus constant, constant, constant. So all these constants, this one plus this one plus this one plus this one plus this one, considered as a single constant value. So therefore x plus this can be considered as y into n. Here x is equal to, I am taking C0 plus C1 plus C4 plus C5 plus C6 plus y is equal to, I am considering here is C2 plus C3. So when we calculate the time complexity of this algorithm is x plus y into n. Here x is a constant and y is constant. Okay, then we total time order of n. We consider here only constant plus constant into n. So we take here only dominant term. That's why here n. We are taking it is a only dominant term. See here, the dominant term is we consider only dominant term. We consider only dominant term. So the big O notation order of n is equal to here x plus yn. We are taking it as dominant term, that is n. The order of n for this program to check whether the given number is either prime or not by using the for loop. Here we calculate by using for loop if the given number, okay, having more than 2 factors or not. If more than 2 factors having, that is considered as not a prime number. Otherwise it is considered as a prime number. In this way we calculate time complexity by using this logic. The same program can be solved, okay, in different manner. So as next class we discuss the logic behind this problem can be solved with another logic, and we calculate the time complexity. Then we decide which one is the best one among these terms. So in this way operating system calculates all the alternative techniques when we are dealing with algorithms. So this is the today's concept. We are discussing this logic. Thank you, students.